Hey everyone, welcome to the video. Today we are going to discuss about step 2 problem B, ropes. So the statement says there are n ropes and we need to cut k pieces of same length from them. And also we have to find the maximum length of piece we can get out of all these n ropes. And it is required that we need to cut at least k pieces. So that's the problem. And the input are like the number of ropes, that is n, can be up to 10,000 or 1e4, and so is k. And the n lines, which contains the length of the individual rope, that can go up to 1e7. Also in the output we have to answer the maximum length of piece we can get, and the judge will consider the answer correct if the relative or absolute error is smaller than 1e minus 6. So we'll understand this problem with some other example, since the values in the given example are a bit bigger. So now let's come to the board. Here I have already written down another example in which n is 7, k is 4, and these are the ropes of the given lengths. So here 7 ropes are given with respective length as 1, 2, 1, 3, 5, 3, 5, and we have to find 4 pieces such that those pieces are of maximum length possible. So let us first try to understand how we can approach this problem brute force way. Think, what is the length which ascertain one thing, that you can always cut these k much of pieces out of all these n ropes. See, also we are considering that the answer always exists. So you have to think what is one length that ascertain that we can always cut k much of pieces. Think about it. So the answer is 0. Yes, we can always cut rope of 0 length, which is a bit absurd, but yeah, we can do it. Like in mathematics term, we can always cut rope in the length of 0, which actually doesn't mean anything. 0 length is nothing, but yeah, that is something certain. Now, can we cut rope of length 1? We have to check. We will see, yeah, we can cut from here. That is 1 piece from this one, 2 piece from this one from this one, then 3 from this one, 5 from this one, 3 from this one, and 5 from this one. So total 20 pieces of length 1 each. Yeah, so we have 4 pieces of length 1, but is it maximum? The question is, can we cut 4 pieces of length 2? Let's check. We can cut 0 pieces from this of length 2, 1 from this, 0 from this, 1 from this, 2 from this, 1 from this, 2 from this. For now, we are just considering integer length only. So we can cut total 7 pieces of length 2, which is still greater than 4. So it's true, we can cut 4 pieces of length 2 as well. Now the question arises, can we cut the pieces of length 3? So from this one we can cut 0, from this one we can cut 0, from this one 0, from this one 1, from this one 1, because we are considering integer length only, from this one 1, from this one 1. So from this we can see that we can cut exactly 4 pieces of length 3, which is still greater than equal to the k, that is 4. So yeah, it's true that we can cut 4 pieces of length 3. Now again the question arises, can we cut of length 4, the 4 pieces? So from this one again 0, from this one 0, 0, 0, from this one 1, from this one 0, from this one 1. Now here we saw that we can only cut 2 pieces of length 4. So which is obviously smaller than 4. So it's not possible to cut piece of length 4 from these given ropes. And if we can cut them, it is smaller than the given k. So until now we found that we can only cut maximum length pieces of 3, which can be at least 4. So we saw that 3 will be our answer in that case. And it is quite obvious, if we can't cut the pieces of length 4, it will not be possible for pieces greater than this. I mean the pieces of length greater than this, 5, 6, 7, etc. But we also saw that we can cut pieces which are smaller than the length of 3, like 2, 1, 0. It's something like we can cut piece of 0 length, that is t, of 1 length, that is t, of 2 length, that is t, of 3 length, that is also t. And from this point onwards, it became f, that is false. And it remained f so on for all the bigger values than 4, including 4. So we saw this bitonic sequence that we discussed in the problem A of step 2. But earlier it was like FFF then TTT, but here it is like TTT FFF. Now before jumping to the binary search, let's see why this brute force solution doesn't work. See, in the brute force case, we have to start with 0 and go until the maximum value possible one by one. And this maximum value can be 10 to the power 7 in the worst case. And for each of this step, we have to search them, like we have to find how many pieces we can cut in the n ropes, like the given n ropes. So we have for each of this length, we have to do n work more, like for each of them, which is again can be maximum 10 to the power 4. So in worst case, it could get up to 10 to the power 11, which is very inefficient and will not work in 1 second as given in the problem. So we have to do something about it. Now comes the binary search thing. How we can apply this? See, we will optimize this part of searching numbers rather than doing from 0 up to 10 to the power 7, let's say in worst case. We will not go one by one, like we will not plus 1 every time from 0 to 1 then to 2. Since we know one thing, that the series is bitonic, that initially everything will be like true, 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 or at least 0 will be true. That's the certainty we are having. And after that, everything will be like false, false, false. So we have that kind of certainty. So we can easily apply binary search on this, as we discussed earlier as well. Now let's see how we can do that. Also before binary search, let me ask you one thing. Can't we simply calculate the total number of pieces we can cut of length x from all the given n ropes? Is it simply a simple iteration and we can divide each of the row with this x and we can count all the pieces like this from all of these n ropes, like with a simple for loop, and for each of the n value, that is I, we can simply plus in our answer, like answer plus equal to I by x, which means I is the length of the ith row and x is the length of the piece we want to cut out from it. So if x is bigger than I, it will be 0, and if I is bigger than x, then it will be according to the division. So it's easy for us to calculate the total number of pieces we will get of length x from all of these n ropes. Now we have to work on the binary search part, which actually tells this x value. Binary search is also easy. See, we know one thing, that we will always have the answer as positive in the case of 0. What will be the case in which answer will always be negative? Think about it. It will be 1e8. Since we know the maximum length of a rope can be 10 to the power 7, so we simply keep it something like 10 to the power 8, which will ascertain that it will surely not going to give us any answer, because also k is at least 1. So in the case of 10 to the power 8, everything will, like every rope will return 0 pieces. So 0 is obviously smaller than 1. So 1e8 will assure that it will return false. So it means if it is here true and here false, transition must have happened somewhere over here in the mid. And it is bitonic, like TTT here, then FFF somewhere at the transition point. So we can simply apply binary search in this. We will always start from L equal to 0 and R equal to 1e8 and keep finding the mid value. If we find a point in which mid is true and mid plus 1 is false, or a point where mid is false and mid minus 1 is true, we can break. Otherwise, if our mid is true, then it means if let's say our mid landed somewhere over here, then we have to search in this part. Otherwise, if our mid landed somewhere over here in the false section, then we have to search in this part. So that's it. That's how we're gonna do it. Till now, we are discussing how we can answer it in integral terms. Like the pieces will be in integral terms only. But in the question, you can see here the answer is 200.5. So we have to answer it in decimal form. And also our relative error should not exceed 1e minus 6 or 10 to the power minus 6. So we have to take care about that. Now, I hope your concepts are clear about the problem. Now let's jump to the code. Here, Firstly, we're gonna take n and k as input, which is the size of the array, basically the number of ropes, and k means the pieces we want. Now we will take array or vector as input of size n, which will contain the length of the ropes. Now we will define a Boolean function, which is also known as a predicate function, which will basically return true if we are able to cut greater than equal to k pieces of certain x length, which basically means, for example, if we are given any array and we are asked if we can cut greater than or equal to k pieces of length 2 from it, then it will return either yes or false. So we'll name the function prd. It will receive the vector a and the integer k, which is the total number of pieces we want to cut at least, and we'll also give it a value x. That's the length of the piece we want to cut out from it, from the given arrays, I mean. So we are giving x as double, since the answer can be in decimal value as well. Now let's write the base case. In the base case, if x is equal to 0, we can always return true in that case, since we can always cut the pieces of length 0, that can be at least k. Otherwise, we will initialize a variable count as 0, and we will count one by one total how many pieces we can cut from throughout the given array of ropes. It will be something like, and if this count is greater than k, then we can return it true. Otherwise, it will return false. Now, this is our function that we require. Now let's come to the main function where we will write our binary search logic. Now we have already taken the value of the array. We will now initialize left, that is the range, which will start from 0, right, which will be up to 1e8, that or 10 to the power 8 as we discussed in the explanation, and a variable mid. Also remember, it was given that the absolute value should not exceed 10 to the power minus 6. So we have to output our answer, which should at least contain 6 decimal digit, but for the safer side, we will output 7 digit. It can be done using the IO manipulation header file, and to get 7 decimal digit as output, we can simply write as set precision and 7. This will print the answer up to the 7 decimal digits and will assure that there will not be any WA in our actual solution, which we will submit. Now we have to work upon the main binary search function. So now I will write the code wholly so that I can explain you afterwards properly what actually I am doing. So in the code, I have initialized another variable LP as 100. Here, I am running a while loop LP times or 100 times exactly, since I am doing LP minus minus. And in this loop, I am calculating mid as L plus R minus L by 2 as the mid value. And if I find this mid value as true in the PRD function, which basically means we can cut k pieces of this mid value from all of these n ropes, then we will do L equal to mid. Otherwise, if it's not possible, then we will do R equal to mid. Now, first of all, let's understand why I am doing this LP minus minus, or why I am running this while loop totally 100 times. Let me ask you another question. How much is log 2 1e18? Let's see. As you can see in the output, it is something 59.7947 or approximately 60, which basically means in a range of 1e18, which basically means if we start our L from 0 and R up to 1e18, and if we apply binary search on this range, then it will only lead to maximum 60 loops. And after 60 loops, we will get our answer. So even though 118 is a huge range, which generally don't occur in our practical cases, it only takes 60 loops or 60 iterations for binary search to work upon it. So to be on safer side, in this case, I have taken LP as 100 which means binary search loop will run LP minus minus or 100 times. And for sure, after 100 iterations, we'll get our answer. Also, this PRD function runs big of n time, and n is 1e4 or 10 to the power 4, and our while loop is running exactly 100 times. So 100 into 10 to the power 4 is 10 to the power 6, which is efficient enough to work in 1 second. And after it gets out of the loop, we can simply print L. Since we saw in the board that the left side always hold the true value and the right value will hold false, and we require this true value only. So that's why we are printing L afterwards. Now let's try to run the code for the given example in the problem. So one thing to note here, I mistakenly said and wrote I in place of AI. It should be AI. That's why we were getting the wrong answer. Now let's try to build the solution. Here we are getting the correct output. Now let's submit it in the problem. And AC. So that's it. I hope you got the solution. And if you have any doubt, you can ask in the comment section. Please like the video and subscribe to the channel. Thank you for watching.